I'm going to introduce Matt Wierman. He's from Virgin Orbit. He is a senior propulsion engineer. So basically, he specializes in getting those rockets into space, all the fiery stuff at the bottom of it. So Virgin Orbit, by the way, also a great friend of the Space Center. They are located just about 7 miles south of us in Long Beach, California. They are actually building rockets as we speak that are going to go into space and sort of push small satellites into space. And Matt's at the top of it. Actually, maybe his work is literally at the bottom of it because it's the propulsion end of the rocket. But he's on top of everything that's going on, all the latest space news, and super excited to welcome him here. So Matt, take it away.
Thanks, Ben. Good to talk to you all today. And in fact, you could say my work is at the bottom because two of the components I personally designed are the farthest back parts of the entire rocket. So yeah, I do make up the back of it. Like Ben said, I work at Virgin Orbit down in Long Beach. It's actually a dream job of mine. I grew up in Central Florida, where the last speaker lives right now, and I got to see shuttle launches from my front porch. I was actually there on the beach at Cape Canaveral watching the final space shuttle launch, and I knew from a very early age that I wanted to work in aerospace engineering. So I went to school. I went to Caltech out here in Pasadena, California, got my bachelor's degree, and then I knew that I really enjoyed school, just loved school. So I went and got my master's, my PhD. So that meant that I really just dove very deep in the studies of aerospace engineering, into rocket flight, rocket propulsion, and then into rocket engine design, which is what I get to do every single day at Virgin Orbit. I've designed with the team together at Virgin Orbit of about 700 people, my parts for the engine, and then also I am heavily involved in testing rocket engines. We do a lot of testing on the ground to ensure that once we release our rocket, that it's ready to fly. We don't get to test lots and lots of rockets. We want to make sure everything's understood before we drop it. So we're gonna get right into it. Let's go to that after that first slide there. All right, so that's our launch pad. That plane that we call Cosmic Girl, it's very different than the way that we launch other rockets, which is from a launch pad, say out here in California at Vandenberg Air Force Base, or at Cape Canaveral Air Force Base in Florida. Those are all based on the ground, launching from almost sea level up to space. We instead carry our rocket aloft on our floating flying launch platform, which is a Boeing 747, and we drop the rocket. That means that we can fly from anywhere in the world and do a launch. We can launch from Mojave, California, from Guam in the South Pacific, from England, from anywhere that has a runway that explores 747, we can launch. All right, let's go on to the next slide. So who we are. So you can see it zoomed in right there. You see our rocket when it's still attached to the plane. And then on the right side, you can see that's from our actual first launch. Back in May, on Memorial Day, we attempted our first launch, which was, it wasn't the full success that we expected it to be. About 3 seconds after ignition, which is the moment you see right here with the fire coming out of the rocket, we actually lost the mission. We had what we appeared to be a liquid oxygen leak inside the rocket. It shut down, and that was the end of our mission for the day. However, we learned a ton, and that's an important thing about being an engineer, recognizing what you can learn not only from success, but also from failure. So since then, that was end of May, we're now in the middle of August. We've learned more of what happened. We learned how we can fix it. We've tested ways that we can fix it, and we already have the best ideas we can put together for how to fix it for our next flight. And we were able to do that entirely without recovering any parts of that rocket that failed. We did it through data by actually understanding the pressure sensors, the temperature sensors, our flow rates, our flight path, all of that great data we were able to process and learn what happened on this, so that the very next day we knew basically what had happened. And then within a couple of weeks, we learned more of what happened and how we could fix it. And now we're gonna go for the end of this year. We're looking to get another rocket flight. Let's go with the next slide. So our rocket, Launcher 1, is meant to launch small satellites, things about the size of your refrigerator. Not the big things that you'd launch on, say, a Falcon 9 or an Atlas 5, but small satellites. Many of you are watching this on your phones, your iPads, your computers. Those are more powerful computers than we ever used to go to the moon. So we can launch things like GPS satellites, space-based internet, Earth orbit imaging satellites, ways that we can better understand our planet and improve communication between all people. At Virgin Orbit, our big slogan is that we boost imagination and that space is for everyone. We want everyone to be able to have access to space. Let's go to the next slide. So that's our Launcher 1 rocket right there. If you want to look all the way to the bottom left, you can see a bit of the engine nozzle skirt for the engine that we call the Newton 3. That's actually the part that I get to work on, is that big boost stage engine, the very first stage engine. It flies for about 3 minutes and then it falls off because it's all empty, it's used up. And then the second stage flies for about 6 minutes and then we've delivered satellite to orbit. It's expendable, which means we use it up. It's one-time use. It uses LOX RP. LOX is a shortened way of saying liquid oxygen because, of course, there's no air in space. So we have to bring our own oxidizer for the fire with us. And RP, which stands for rocket propellant, which is kerosene. It's sort of like the stuff you'd put in a gas-burning car. It's about 70 feet long, which is not the largest rocket in the world, but we're looking for responsive launch, small satellite launch. And that's just the right size for that. Let's go to the next slide. Here's another look at all the things that go in. I'm just a propulsion engineer. If you look in the top right there, you can see a Newton 3 hot fire test. That beautiful fire flowing out of the engine, but that's only one small part of it. We also have GNC and avionics. That's guidance, navigation, control, and avionics. Those are our computers. That's how we control where the rocket goes, where it points, where it steers, how it interprets the data that it's generating itself. The whole big white thing that's covered in, that's a structure built of composite materials. It's sprayed on with a foam to insulate the propellants that we have inside. And there's our factory. You can see in the middle, in the picture, that little bubble there. That's our factory in Long Beach. We build it all there. There's about 700 people that work in Long Beach and Mojave together where we have our test site. And every one of us is necessary for getting our rockets from the ground to space. People that sell it, people that build it, people that design it, the people that test it, people that check it out. There's people from all sorts of backgrounds, PhDs like me, people that have bachelor's degrees, people that have technical backgrounds, like welders and builders. We need all sorts of people to be able to launch things into space, and everyone can be a part of it. That's pretty much everything I have to say about Virgin Orbit right now for you all. It's an exciting place. It's definitely my dream job. I dreamed of doing this since I was a little kid. So it's exciting that I get to go to work every single day to enable greater access for people to space.
That's awesome. That's awesome. Thank you very much. And that's great. I'm glad that you talked about how you've been inspired to do this since you were a little kid, because we actually have a couple of questions from kids out there. So Barbara Snyder, who I'm assuming is speaking for someone, because the question is, we have an eager young learner with an intense draw to the unknown. Any resources you would suggest for young kids to focus on to support their natural curiosity of aerospace engineering? I want to meet this kid, by the way, who has a natural curiosity for aerospace engineering. That's very specific. It's great.
Oh, I love it. And I find kids having great natural curiosity for everything because they just want to learn. And that's a beautiful spark. I'd say one of the best things is this is almost cliche, but your local public library. There's so many books there. I remember when I first fell in love with space, I read every single book that I could possibly read in the library on space exploration, including one that I found that was about the moon's geography, published in 1965, before we had any real pictures of the moon, and it had mountains on the moon, which the moon doesn't have mountains. So that was really hilarious looking back. There's also just look for opportunities to see and touch things in space. I'm a rocket scientist. I love talking about it. it's really easy to find people that work in aerospace that want to talk about it and share their own experiences. I had the blessing of, when I was a kid, of living near where aerospace and engineering was taking place. I could literally look out the front window of my house during a space shuttle launch and see it. When the space shuttle came to land, I could hear that sonic boom.
Oh, jeez.
And it was just one of the coolest things in the world. My dog hated it. It was just really great to be there and be a part of it. And get to go to places like Kennedy Space Center, or like here locally at the Columbia Space Center. I did a Challenger experience when I was a kid, like you all have. Right. And that, to me, is just one of the coolest things I ever did when I was a kid.
That's right.
Even when I sit on console now for rocket test operations and for engine tests, like, I still think back to that first time I was sitting on a console, like playing pretend, but practicing the things that I do now.
Sure. Oh, that's super cool. And I'm glad you said that. Thanks for plugging the Space Center. I think that for kids in Southern California, there's a hotbed of rockets here. There's, Caltech is, spilling out engineers all the time. Florida is a big hotbed of rocketry, but we probably have viewers right now from all over the place. I think everybody's got a library. There might be some really enthusiastic teacher in town that you can kind of talk to about this stuff. But also, now, especially now that you can't visit like the Space Center or the Kennedy Space Center or something like that, these kind of online connections are out there. Is there any place that you go, or that any sort of websites or anything like that you can say that, hey, public, if you're really interested in space, this is what you should be checking out?
Yes, I follow sites, of course, like nasa.gov. That's NASA's like front page of the work that they're all doing. And there's great information there for the general audience, for adults, and even great projects for kids. Another one of my favorites is spaceflightnow.com. They have a long list of all the rocket launches that are coming up over the next year. And I definitely remember the day when Launcher One first appeared on that. And that was a really exciting thing. It's like, oh my gosh, we're on spaceflight now.
Sure.
And they'll usually have a like step-by-step, like blow by blow of what's going on leading up to a rocket launch. So you can see all the people involved, all the steps that take place. Everyone watching those, the ESSE's model rocket launches. That's pretty simple. You load in the engine, you put the igniter in, you plug it, you put it on, you launch it. There's more to it. Everyone be safe. Yeah. But that's a pretty simple step that takes about 2 or 3 minutes to all set up. Our procedure for our first launch was about 72 hours.
Whoa.
Printed from beginning to end. And that's because it takes all those steps to make sure everything is done completely and done right, and most importantly, done safely. If you're all looking for an activity to do that involves space, if you don't have like being near a space center or a space museum, is to build a model rocket. You get to do everything that we engineers and like technicians all get to do all on your own. Doing those sorts of experiments. See what makes it go high, what makes it stay in air long. Those are all the things that I did when I was a kid. There was even one that had a camera in it, and I thought that was awesome. They definitely advanced. When I was a kid, the camera actually had assembled part by part, and now it's just a small digital camera that sits inside the. So there's all sorts of cool projects that are available to you to play a part in space.
That's pretty cool. And hey, actually these questions are coming. So by the way, thank you for mentioning that you can get your hands on rockets. So all the Estes rockets that we're launching today, those are available online at the Estes website. So the question that I asked you before about, what resources are out there, this is actually a 5-year-old girl who's asking these questions, and it looks like
that's awesome.
She lives in Long Beach, so she's wondering if she could visit sometime. But her exact question is, how many hours and days does it take to assemble a rocket engine?
Oh, that's a wonderful question. Okay, I'm going to go with visiting Virgin Orbit first. We partnered with local schools, colleges, and trade schools to get lots of people, including the Columbia Center, to bring students of all ages and technical backgrounds in to visit our factory. We want us to be open. That's something that I even started and I really champion, because I don't want aerospace engineering to be this thing that's like, oh, I'm not good enough for that. Oh, other people do that.
Right.
Everyone can have a part in it. And part of it is getting to see it happen with people that you know. And being in Long Beach, you can drive the north side of Long Beach Airport and see the Virgin Orbit like logo right there on the building. We're not doing tours right now because of COVID concerns. Sure. But my hope is that when things get better, we will resume those tours to get more people inside to see what we're doing. The next question was, how long does it take? It takes a long time. We're always trying to do it in less time. We're a business, so obviously getting launches out, launches done. That's what our customers pay for. They don't pay for us to necessarily like open space for everyone and build rockets. They want their satellite in space. Sure. Just like you pay the postal service to mail your mail and mail your packages where you want them to go. That is what you care about. So for us, putting together a rocket engine takes probably about 2 months. Okay. Like plus or minus a month. We're always trying to figure out ways, how do we do this faster? How do we do it more efficiently while not sacrificing the quality of our builds? We're also, it's not just the build, it's also the testing part. And as a responsible engineer for testing, which is what I do, I pay a lot of attention to, okay, how can we make this procedure go faster? How can we improve this step? How can we better anticipate things that are going to fail so we have a spare part on hand and we're prepared for that, rather than say, hey, we need to spare, okay, let's get it from Long Beach. Well, that's 2 hours away. And it might be late, so the crew might not be in to hand the part over. Those are all things that we think of logistically to make sure things are ready when we need to test them, and that we also are ready to learn from the data what we need to do next. Cool. There's always, we're looking to take it from being a long process to being a shorter process. That's cool. I'd love someday like an assembly line of rocket manufacture.
I do have to say,
and to actually build off of that, another thing that we're doing is using new technologies, not just being smarter about building things, but we have a building robust 3D printing like capability where we are taking parts of like components of an engine that would normally be about 10 or 12 parts and tons of fasteners and seals and making it one single 3D printed part that takes hours to manufacture instead of days of manufacture, assembly, testing, leak checking. It's all one part. Those are all ways that we are improving our process by being smarter and trying new things. Rocket engines honestly really aren't that different than what was built about 70 years ago. And only now with these new manufacturing technologies and new physical understandings are we making them different than that. And that is what will propel us into the future.
That's cool. That's cool. Well, that's the question for 5. I have a super quick question because we're going to have to get to some more rocket launches, but this is a social media handle called I Love Cupcakes, which I had to say on air. Actually, this person is saying, this is so cool. I was wondering how many times you test a rocket before you launch it.
It's a good question. Well, it's really hard to, because we have an airdrop, it's really hard to, drop the rocket and then reel it back into the plane. We don't yet have that capability. So we're kind of like, we're committed once we drop the rocket. Sure. But as far as testing goes, we'll generally test an engine anywhere between 2 and 5 times to dial it in, to check its performance. But then we're doing tests all along the way when we bring it back to the factory, when we integrate it with the rocket, when we put the 2 stages of the rocket together, when we ship the rocket up to Mojave. There's tests all along the way. And those are the ways that we build our understanding of a vehicle before we drop it. Because like I said, once we've dropped it, we're committed.
It's gone.
The goal all along the way is to build understanding and to improve safety.
That's awesome. Awesome. Well, hey, thanks, Matt. It's been great. It's great to see you again in this COVID time, even though it's virtual. And thanks again, not only to you, but also to Virgin Orbit for maintaining Southern California's rocket supremacy out there. But yeah, thanks a lot. Thanks for this.